We have already discussed question start with the question 16 in this video.
16, we have in a class of 37 students, 12 students like novels, 19 students like comic books, and 8 students like both. How many students in the class like neither novels nor comic books? So, for this, first we will see what is given information. So the given information is total number of students number of students who like novels. Number of students who like comics, and the number of students who like both. Now what we have to suppose to find. Number of students who like neither novels nor comic books. Now let N and C be the sets of students who like novels and comic books, respectively. Now in the question, the number of students in a class is given, and it will be denoted by n of eta, the universal set, and that is equals to 37. Number of students like novels will be denoted by n of n, and that is equals to 12. Now the number of students like comics, that will be denoted by n of c, and that is equals to 19. And the number of students like both will be denoted by n of c intersection n, that is equals to 8. Now we have to find out the number of students who like only novels. So the number of students who only like novels will be equals to n of n minus n of n intersection c, and that is equals to 12 minus 8, and after subtraction we will get 4. Similarly, we have to find out the number of students who only like comics is equals to the n of c, number of students who like comic, minus number of students who like both. So 19 minus 8, and that will be equals to 8. Now we will draw a Venn diagram to understand the word problem easily. So here we have a universal set eta represented by a rectangle. Inside it, we have two overlapping circles representing the sets n and c respectively. Now there is no need to write down all the elements of the set in a Venn diagram. We can just write down the number of elements in the Venn diagram to understand the problem. So the number of students who like both is 8, and it will be right down in the overlapping region. The number of students who like only comics, we have find out that is 11. And the number of students who like only novels, that is 4. Now we have to find out the number of students who like neither novel nor comic, and that will be denoted by n of c complement intersection n complement, and that is equals to, we will simply take away number of students who like only novels, number of students who like only comics, and the number of students who like both. And after simplifying, we will get 14. So the number of students who like neither novel nor comic is equals to 14. And we will write down 14 in the universal set eta in the Venn diagram.
Now in question 17, in a group of people surveyed, 23 of them on laptops, 17 of them on desktop computers, and 9 of them on both type of computers. How many people in the group on their laptops or desktop computers, but not both? So the given information is number of people who on laptop, number of people who on laptop, number of people who on desktop computers. and the number of people who own both types of computers. Now we suppose to find number of people who own either laptop or computers or desktop computers. But not both. Now we will find out number of people who own only laptop. And we can find out it just by subtracting the number of people who like both types of computers from the number of people who own laptop. So we will subtract 9 from 23 and we will get 40. Now we will find out the number of people who own only desktop computers. And now we will find out it by just subtracting the number of people who own both types of computers from the number of people who own desktop computers. So we will subtract 9 from 17 and we will get 8. Now we will find out the number of people who own either laptop or desktop computers. But not both. So to obtain this, we just have to add up the number of people who own only laptop and the number of people who own only desktop computers. And those are 14 plus 8 respectively. And after adding these two numbers, we will get 22. The number of people who own either laptops or desktop computers, but not both, is equal to 22. Of the question 18. The set eta A and B satisfy the conditions. Number of elements in the universal set eta is equal to 17. N of A is equals to 8, and the number of elements in the set B is equal to 12. We have to find out the largest possible value of N of A union B whole complement. Before solving this question, we have to understand some concepts. So suppose number of elements in a set A is greater than equals to number of elements in the set B, then N of A intersection B is largest and number of elements in the set A union B is smallest when B is a subset of A. And on the other word, n of A intersection B is the smallest, and n of A union B is the largest. Then we have two conditions. The first condition is if A intersection B is equals to 5, it means A and B are disjoint sets if n of A plus n of B is less than equals to n of eta. Now in the second condition, A union B is equals to 5 is equals to A union B is equals to eta if n of A plus n of B is greater than n of eta, the universal set. So it means A and B can't be disjoint sets. Number of elements in the set A union B whole complement is largest when n of A union B is the smallest this will occur when A is a subset of B. So the largest possible value of n of A union B whole complement will be equals to 17 minus 12, and that will be equals to 5. We can understand this easily with the help of Venn diagram. So here we draw a rectangle to represent a universal set eta. Then we have two sets A and B, and A is a subset of B. And now we will write down the number of elements in the set B, that is equals to 12. And the number of elements in the set eta is 5. So to find out the largest possible value of n of A union B whole complement will be find out by just subtracting the number of elements in the set B from the number of elements in the set eta, and that is 17 minus 12. That will give this equals to 5. Now in the part 2, we have to find out the smallest possible value of n of A union B whole complement. So n of A union B whole complement is the smallest when n of A union B is largest. And this will occur when A union B is equals to universal set eta. So n of A union B will be equals to n of eta, and that is equals to 17. So now the smallest possible value n of A union B whole complement will be equals to 17 minus 17, and that will be equals to 0. So the smallest possible value of n of A union B whole complement is equals to 0.
In question 19, the sets eta, x, and y satisfy the conditions. The number of elements in the universal set eta is equals to 25. The number of elements in the set x is equals to 17. And the number of elements in the set y is equals to 9. So we have to find out the smallest possible value of n of x intersection y whole complement. So for this, in the part 1, number of elements in the set x intersection y whole complement is the smallest when n of x intersection y is largest. And this will occur when y of x, then this will occur when y is a subset of x. Now in the part 2, we have to find out the largest possible value of the set x intersection y whole complement. So for this, n of x intersection y whole complement is largest when n of x intersection y is the smallest. This will occur when x union y is equals to universal set eta. So it means number of elements in the set x union y will be equals to number of elements in the set eta, and that is equals to 25. And now the smallest possible value of n of x intersection y whole complement will be find out by subtracting the number of elements of the set y from the number of elements of the set eta. So the values are 25 minus 17, 25 minus 9 respectively. And after subtracting, we will get 16. So the smallest possible value of n of x intersection y whole complement will be 16. To understand the situation in a well-mannered way, we will draw a Venn diagram. So for this, we will draw a rectangle representing the universal set eta. Inside it, we will draw two overlapping circles representing the sets x and y. Now we will fill in the respective information. The number of elements in the set x will be 16, and the number of elements in the set y will be 8, and their intersection is 1. No. Now the largest possible value of n of x intersection y complement will be equals to 16 plus 8, and that will be equals to 24. We came to know these values from the Venn diagram. So the largest possible value of n of x intersection y whole complement is equals to 24. Now in the question 20, the sets eta A and B satisfy the conditions. Number of elements in the universal set eta is equals to 25. Number of elements in the set A is equals to 15, and the number of elements in the set B is equals to 9. So we have to find out the largest possible value of n of A union B whole complement. Now in the question 20 part 1, we have to find out the largest possible value of n of A union B whole complement. So for this, n of A union B whole complement is largest when n of A union B is smallest. This will occur when B is a subset of A. So the largest possible value of n of A union B whole complement can be found out by subtracting the number of elements of the set A from the number of elements of the set eta, and the values are respectively 25 minus 15, and we will get 10. So the largest possible value of n of A union B whole complement is equals to 10. Since n of A plus n of B is less than n of eta, so n of A union B whole complement is the smallest when n of A union B is largest. And this will occur when A intersection B is equals to 5. It means A and B are disjoint sets. So the smallest possible value of n of A union B whole complement will be equals to n of eta minus n of A minus n of B. So writing down the respective values, 25 minus 15 minus 9, and it will gives us 1. So the smallest possible value of n of A union B whole complement is equals to 1.